Hello, we're going to go through 6.3 section, which is binomial radical expressions. We're going to start with adding and subtracting radical expressions. So the first problem we have 3 times the square root of 5x minus 2 times the square root of 5x. For adding and subtracting, it's a little bit different rules than multiplying. For adding and subtracting, the roots need to be the same, and then what's underneath the roots need to be the same. Whereas for multiplication, just the roots need to be the same. So to get that straight, if we have the square root of x, or the cube root of x, sorry, times the square root of x, we're not going to be able to multiply those because the roots are different. But if they were both cube roots, then we're going to be able to multiply them. It doesn't matter if maybe this one has xy underneath and this one has an x, if they're the same or different, but just the roots need to be the same when you're multiplying or dividing. Now for adding, the roots need to be the same and what's underneath needs to be the same. So the root and what's underneath the radical needs to be the same when we're adding and subtracting before we can combine them. So to start with, this one, notice there's square root of 5x, square root of 5x. They're both square roots. They're both 5x underneath. So we can go ahead and add and subtract them. So we're going to add or subtract the numbers out in front, leave the radical and what's underneath alone. So 3 minus 2, we get 1. And then square root of 5, we just tack on the end. So it would be 1 square root of 5, or you can just put square root of 5. This next one, notice we have 6x squared times the square root of 7 plus 4x times the square root of 5. Notice this one's square root of 7, this one's the square root of 5. The roots are the same, but what's underneath is not the same, so we cannot go ahead and add those. This next one, we have a cube root of 7xy, the fifth root of 7xy. Notice that the 7xy is the same, so that's good, but this one's cube root, this one's fifth root, so we cannot go ahead and simplify those. This next one, we have the cube root of 5 and the square root of 5. Again, what's underneath is the same, but the roots are different, so we cannot go ahead and simplify those. Alrighty, let's take a look at more that we can actually go ahead and simplify. So each of these, notice square root of 12 plus square root of 75 minus the square root of 3. They're all square roots, so that's good, but what's underneath is all different. So right from the start, we cannot go ahead and just add them together. But notice this square root of 12, we can do a factor tree and simplify that. So let's go ahead and simplify these and then see if they're like terms. So 12, if we do our factor tree for 12, we get 2 times 2 times 3. 75, we get 5 times 5 times 3. And then 3, we're just going to leave it as square root of 3. We're going to bring out our pairs because it's square roots. So we have a pair of 2's here, a pair of 5's here, and then no pairs here. So this is going to be 2 times the square root of 3, 5 times the square root of 3, minus, and then square root of 3. Now notice they're all square roots of 3 now, so now they're all like terms, so now we can combine them. So we're going to add and subtract the front numbers, leave the square root of 3 alone. So 2 plus 5, we get 7, minus the 1, we get 6. So we'd have 6 square root of 3. If we take a look at this next one, they're all cube roots, so that is good, but underneath they're not the same, so we're going to do our factor trees. So we do our factor tree for each of these numbers. And then this one's the cube root, so we need to put them in groups of 3. So we have a group here, so we can bring out a 5, a group here, so we can bring out a 3, and then a group of 2's here, so we can bring out a 2. So this first one would just be 5 times the cube root of 2. This next one, 3 times the cube root of 2. This next one, 2 times the cube root of 2. Now notice they're all cube root of 2, so we can simplify this. So 5 plus 3, we get 8, minus 2, we get 6. So 6 cube root of 2 would then be our final answer. The next section, we're going to go ahead and multiply binomial radical expressions. So notice for this problem, we're going to go ahead and FOIL or distribute. So this first term, this 4, we're going to distribute it to both of these terms in the second set of parentheses. So 4 times 5, we get 20. 4 times 4 square root of 2. How we're going to multiply those, what's on the outside of the square root sign, we're going to multiply together. What's on the inside, we'd multiply together. So 4 times 4, we get 16, and then nothing's underneath here, but there's a 2 under here, so times the square root of 2. Now we're going to go ahead and distribute the 2 square root of 2 to both of these. So 2 square root of 2 times 5. 2 times 5, we get that 10. And then the square root of 2 we leave alone. And then 2 square root of 2 times 4 square root of 2. We're going to take what's on the outside and multiply it together. So 2 times 2, we get that 8. What's on the inside, we're going to multiply that together. So square root of 2 times square root of 2, we get square root of 4. And then we go ahead and we want to simplify this down. So square root of 4 is, we have 2 2's, so we can bring out a 2, so we just have 2 here. And 8 times 2, we get 16, and then 16 plus 20, we can go ahead and combine those and get 36. And then this 6 square root of 2 plus 10 square root of 2 are like terms, so we can go ahead and combine those. 16 plus 10, we get 26 square root of 2. And then this 16 and this 20, we get 36. They're like terms. From here, 36 and 26 square root of 2 are not like terms, so that is our final answer. Let's do another one of these. So we have 3 minus square root of 7 times 5 plus square root of 7. So we distribute this 3 to both of them. 3 times 5 is 15. 3 times square root of 7 is 3 square root of 7. And then we're going to distribute this. Negative square root of 7 times 5 is negative 5 square root of 7. Negative square root of 7 times positive square root of 7 is negative square root of 49. We're going to go ahead and simplify this down. Square root of 49 is just 7, so we'd have minus 7 at the end. 3 square root of 7 minus 5 square root of 7 is like terms, so we can combine them and get negative 2 square root of 7. And then 15 minus 7, we get 8. So 8 minus 2 square root of 7. If you instead put negative 2 square root of 7 plus 8, that would be a correct answer also, so the order does not matter. This next one, we're going to go ahead and distribute the 3. So we have 3 times 2, we get 6. 3 times 4 square root of 5 would give us 12 square root of 5. Now distribute the 2 square root of 5, so 2 square root of 5 times 2 is 4 square root of 5. 2 square root of 5 times 4 square root of 5, multiply what's on the outside, inside on the inside. So 2 times 4 gives us 8, 5 times 5 gives us 25. We're going to go ahead and simplify this down. Square root of 25, if we do our factor tree, is 5 times 5. We bring out our one pair, so a 5. 6, and then this would give us 40, so 6 plus 40 would give us 46. And then we have 12 square root of 5 plus 4 square root of 5 is 16 square root of 5. These are not like terms, so that would be our final answer. This next one, we're going to keep multiplying, so we're going to go ahead and distribute this 5. 5 times 5, we have 25. 5 times square root of 7 is 5 square root of 7. Now distribute the negative square root of 7 times 5 is negative 5 square root of 7. Negative square root of 7 times positive square root of 7 is negative square root of 49, which 49, the square root of it is just 7. So we have 25 minus 7. We end up with 18. And then these are just opposites of one another, so they're going to cancel out. So we end up just with the 18. So notice if our first terms are the same, our last terms are the same, but we have opposite signs in the middle, then that's going to end up happening. The middle terms will cancel out. Alrighty, just looking at this one, the same is going to happen. The first terms are the same, last terms are the same, opposite signs, so expect those middle terms to cancel out. So distribute this 6. We have 6 times 6 is 36. 6 times square root of 12 is 6 square root is 12. Now distribute the negative square root of 7, or negative square root of 12 times 6. So we have negative 6 square root of 12. Negative square root of 12 times positive square root of 12 is negative square root of 144. These middle terms are opposites, so they're going to cancel out. And then the square root of 144 is just 12. We can either put that into our calculator or do our factor tree, bring out our pairs. 36 minus 12, then we get 24. Alrighty, the last section in this part is rationalizing the denominator. So if you remember, we cannot leave a radical in the denominator. So if we have two terms in the denominator, how we're going to get rid of that radical is we're going to multiply by the same two terms, but we're going to switch the sign in the middle, just like up here, so that our square roots end up canceling one another out. Now if we multiply that across the bottom, we're going to have to multiply it across the top also. So for this one, again, we want the same two terms, just switch the sign. This was negative, so now positive. If we multiply this across the bottom, we need to multiply it across the top also. And then we're going to FOIL, or distribute. So distribute this to both of these terms. Square root of 5 times square root of 5 is square root of 25. Square root of 5 times square root of 2 is square root of 10. Now distribute this negative square root of 2 to each of these. So negative square root of 2 times positive square root of 5 is negative square root of 10. Negative square root of 2 times positive square root of 2 is negative square root of 4. And then we're going to distribute across the top. So 3 square root of 2 times positive square root of 5 is 3 square root of 10. And then 3 square root of 2 times positive square root of 2 is 3 square root of 4. And then from here, we're going to go ahead and simplify this down. So square root of 4 is just 2. So we're going to have 3 times 2 here, or 6 there. 10 is just 2 times 5. We don't have a pair of anything, so we can't simplify that down. Here we have square root of 25 is just 5. These middle terms cancel out because they're opposites. And then square root of 4 is just 2. So we're going to have 5 minus 2 in the denominator. And then we're going to keep simplifying down. 5 minus 2 is, we get 3. And then from here we had 3 times the square root of 4. So 3 times 2, we got the 6 here. These are not like terms. We cannot go ahead and simplify that down. So we can leave this as our final answer. Notice each of these can divide evenly by our 6. So we can simplify it further. 3 divided by 3, we just get 1. 6 divided by 3, we get 2. So our final answer could be 1 square root of 10 plus 2. Let's do one more of these. Again, we have a radical in the denominator. We can't leave that as our final answer. So when there's two terms, we're going to multiply by the same two terms, just switch the sign. This is negative, so we want to multiply by same two terms, just opposite sign, so positive. And if we multiply that across the bottom, we need to multiply that across the top. You're going to go ahead and distribute across the top. You should get to this. You're going to go ahead and distribute the square root of 3 to both of these. And then distribute the negative square root of 5 to both of these. Give you some time to do that, or you can pause this. You should end up with this. And then we're going to go ahead and simplify it. So to start with, square root of 21, we get 3 times our 7. We don't have a pair of anything, so we can't reduce that. 35 is 7 times 5. We don't have a pair of anything, so we can't simplify that. They're not like terms. They're both not the square root of the same number. So we leave those separate. And then the middle terms are opposites, so they cancel out. Square root of 9 is 3. Square root of 25 is 5. So we have 3 minus 5, or negative 2 in the denominator. And then we can leave that as our final answer. Or notice both of these numbers divide evenly by 2. So 2 divided by negative 2 is negative 1. Square root of 21. 2 divided by negative 2 is negative 1. And then square root of 35.